Howdy folks, welcome back to another CS 120 honors lecture. In today's video we're going to be talking about enums and matching them in Rust. So we're going to briefly review match statements, go over some of the examples we introduced yesterday, then talk about enums, what they are, why they're important, and then talk about two of the most common enums you'll see in Rust, the result type and the option type. And then finally, if we have some time, we'll go over some control flow with enums and match statements. So a couple of quick announcements. So homework 1 is going to be due in 5 days on the 7th. Homework 2 is going to be releasing today, due on the 9th. And MP0 released yesterday, due on the 15th. So if you want some help on MP0, come to office hours. If you want to work with your peers, work with the staff members on completing your MP, come to discussion. We'll be having a sort of live coding session, and we'll be helping you out with the live office hours there. So come to discussion, come to office hours if you need help with MP0. Use the core staff. We're resources here to help you. Anyways, on to the lecture. So we talked about the match keyword in the last lecture. So match allows you to compare some value against a series of patterns, and then you execute code based on whichever pattern that your value matches. So we said patterns can be made up of literals, variable names, the wildcard, and we said that there's some more things that are considered a pattern. Well, enums are also patterns, and we'll show you why in the next few slides. And we also said the patterns you try to match must be exhaustive. So if you're trying to match an integer, you either have to list every single integer possible or use a wildcard. If you're trying to match a string, it's nearly impossible to type out every possible string because the list of all possible strings is infinite. So use a wildcard or try and bind it to a variable. But at the end of the day, your match statements must be exhaustive. Okay, so this is the very first example we talked about match with. So we're trying to match a number. Number literals are patterns. So we're saying here 124, then an arrow, and then the value we want to sort of put into professor. Same thing again with 128, 173, and 225. And notice our match is exhaustive. We cover 4 potential integers as our pattern, and we have a wildcard here in case we don't match any of those 4 integers. So the wildcard makes this pattern exhaustive. Same thing with the strings, the &str. We have a capital S string from this function, and so we need to convert it to an &str, since only &strs count as patterns in Rust, not strings. So we list out 4 potential strings we can see as our pattern, and then we also have the wildcard, which ends up making our match statement exhaustive. Okay. And then we talked about tuple destructuring and variable bindings. So we can match tuples. We're matching a triple here. We can match a tuple with 4 values, 5 values, so on and so forth. Tuples don't need to be the same type. So you could have an &str here. You could have a Boolean here, whatever it may be. We're just using integers in this example. But we said we can use a wildcard in specific spots we don't care about. And likewise, we can use the range notation, the 2 dots, to say that we don't care about the particular range of values that this range is taking up. So in this 128 case, we don't care about the last 2 numbers. In this case, we don't care about the first 2 numbers. We only care about 2002s at the end. And then we said that we can fill in a variable here and say that whatever value occurs in this spot of the type, we're going to put it into A. And so then we can use A on the right-hand side in our little code expression. And this statement will match only if we see a 1 and a 1 here. And then we also said that variables act like wildcards. So in this example, we have all 3 spots of our tuple filled with variables. So if neither pattern above matches, then we'll hit this pattern by default. This acts as our wildcard, but in this case, we're saying that we want to use the values x, y, and z in our little code snippet that comes after that pattern, and we do, and we're able to add them up. So this use of variables is going to be very important when it comes to enums, specifically result and option. Okay. And then this is just some more sort of fancy syntax with matches. You can do some range matching. The vertical bar says you can do some pattern or another pattern or another pattern, and reuse that same little code snippet. And then we can bind the result of this range match into a variable, and then go on and use that variable. And our code snippet does not have to be one line. It can be something within curly braces. It can be an if statement, another match statement, whatever it may be. All that needs to be on the right side is some expression that evaluates to a value. And here we have an if statement, example of that. And then finally, our little variable here acts as the rest of the pattern. It makes our match exhaustive. Okay. So now on to enums. What are enums? Enums are a custom type with restricted sets of values. So this can be colors of the rainbow. There's a finite number of colors that you can see in the rainbow. An undergraduate student level, freshman, sophomore, junior, senior. It could be the days of the week. There's only 7 of them. Or HTTP methods or HTTP response codes. You have a finite set of values and you want to model them with a type. So you can express them with an enum. So enums in general make your life as a programmer a whole lot easier. Rather than trying to chase down whether some type is valid, by definition of Rust's type system, if some variable is a particular enum type, then it is restricted to that set of values. It can't be anything else. Well, I'll explain this in the next couple slides. So enums are also considered patterns in Rust. We can match them, which makes them a whole lot more useful. Okay, so why do we need enums? Well, take the day of the week example. What if we tried representing the day of the week as a string or an integer? If it's a string, we can just type out Monday, Tuesday, Wednesday, Thursday, Friday, so on. But what happens if we forget to put this to uppercase, or let's say we end up making a typo? We will have to do that string parsing ourselves. The programmer will have to take care that the variable that's passed in as a day of the week string is actually valid. If you take an integer, 1 is Monday, 2 is Tuesday. Well, what if your variable that is representing your day of the week is something you didn't consider, say -1 or a 0? The programmer has to do the type checking and to make sure that whatever input that they're representing a day of the week as is actually valid. So what happens if the variable containing our day does not match what we expect it to be? If it's outside of the range of possibilities or something we didn't consider, do we throw an error? Do we crash the program? That makes things sort of hard to decide. It makes the requirements very vague. Enums help us fix that. So enums prevent this by restricting the values a type can take on to a small set of values that you, the programmer, specify. So if you want your day of the week and you make a custom type that's day of the week, that's an enum, it can only be 7 values, Monday, Tuesday, and so on and so forth. There's no sort of edge case where you're passed in a -1 or you're passed in a string that's lowercase. It is quite literally just the 7 days of the week. Okay, so we talked about sort of representing things with enums. So let's actually see what that looks like in Rust. So we use the enum keyword to create our own custom enums. So we start our little block of code with the keyword enum and then the name of the type. So in this case, we're saying our type is called day of the week. And in curly braces, we list all the possible types of values that the day of the week enum could take on. So Monday, Tuesday, and so on. It is impossible for day of the week to be any value other than these 7. That is the important thing. There's no sort of edge cases where we have an integer representing our day of the week and we get some integer we're not expecting, or a lowercase string when we're expecting all caps. Rust will not compile your code if your day of the week is not one of these values. So you get that safety guarantee and you don't have to do any sort of sanity checks. Okay. So to define our own custom, or rather to use the custom enum we defined, we simply use the type of the enum, day of the week, 2 colons, the scope operator, and then the value we want. So day of the week, colon, Thursday. And we use the same variable let binding as you are familiar with. And like I mentioned before, we can match enums. So we can match some variable, day of the week, where day of the week is of type, day of week. And we have this exhaustive match. So if we see a Monday, we'd say ugh. If we have a Tuesday or a Thursday, that's a 128 honors lecture drop. Saturday or Sunday is the weekend. Otherwise, it's a weekday. So we can still use this underscore wildcard, or if we wanted to, we can just list out these 7 values. Remember, match statements have to be exhaustive, and the only types an enum can be, or this day of the week enum can be, are the 7 that we listed. So we really only need 7 cases. If we wanted to, we could omit this wildcard and simply just list Wednesday and Friday. Okay. So now I'm going to talk about the option enum. So from the documentation, the option type represents an optional value. Every option is either sum and contains a value inside that sum, or none and does not contain a value. So these are really, really useful for functions that are not defined over their entire input range. So what does this mean? Well, if we have some function that returns some value that a particular input could be invalid for, we can just return null, or rather none. This is similar to returning null or the null pointer in Java or C++, except there's no more null pointer exceptions. You're not dereferencing a null pointer, none of that sort of nasty business. Well, kind of, and you'll see why. Okay. So from the past lecture, we had this example where we're getting a course number and matching that course number, and then returning some string based off of that. Well, we can sort of expand on that. In the previous example, if we hit this wildcard case, we just returned the empty string. Well, we don't need to in this case. So our match statement is not defined for values other than these 4 we listed. So we can just return a none. We have an optional sort of value or return type, an optional string. So only when we hit these 4 cases do we return sum with some value inside. So this is how you construct the sum type and the none type. You just say sum and then in parentheses whatever type you want to be putting inside it. The none, there's no type inside, so no parentheses needed. Okay, let's see some examples in action. So we have this example here, get professor. It takes in an integer, returns an optional string. And so we said that we return none if our function is not defined over some particular input, and our function is not defined on numbers other than 124, 128, 173, and 225. So we try to match the input course. If we see something we like, if we see something we know, we can return a sum with that string inside. Otherwise, we return none and nothing inside. Okay, so we're able to sort of use the fact that this value is optional. Rather than checking if some pointer is null or some value is 0 or some other error no is some error code in C, we have these convenience methods that we can call on our option. So as you can see from that VS Code is telling me that getProf returns an optional string. Professor is an option type with potentially a string inside. And so we can use the isNone or isSum methods to check whether there is, what the return type is, what the option is. So if professor is none, we can print one thing. If professor is sum, we can extract the value inside. So you'll notice this comment here, be careful. I strongly, strongly encourage you to only use unwrap after having called isSum. So unwrap will crash the program if you're trying to unwrap a none value. So if professor is none, our program will crash, panic, and burn down your computer. Do not use unwrap if you have not checked whether your type that you're trying to unwrap is already sum. Please be careful. This will help you in debugging your MPs. Do not use unwrap unless you are 100% sure that your variable is of type sum. Okay, let's run this example. So we have an array of courses, and we're going to try and match each one. So getting the professor for 124 gave us Professor Challen, 128 gave us Nowak, so on and so forth. And once we hit 361, our match statement returns none, and so we enter this little is none if statement, and it's unclear who teaches CS 361. So I mentioned we can also match options. So match professor. And we said that our match statements have to be exhaustive. And we know that options can only take two possible values: sum with something inside, or none with nothing inside. So you'll notice I have these parentheses here. And there is a value inside this sum. And if you recall from tuple destructuring, we can bind that value to a variable. So we can say some name is inside the sum value. And if we hit this match statement, if we hit this case, then we can use name in whatever line of code we have following. None has no such value inside, so there's no variable to bind to. So we simply just say none with the arrow, and we can do the same thing here. Just print out that. So there's two ways to handle options. We can either match them or use the isNone or isSum method. Using isSum or isNone is better if you only really care about one case or the other. If you care about both cases, if you want to handle both cases, use a match statement. It's a little bit cleaner. And it allows you to do this little variable binding. There are ways to do that variable binding in if statements, but that is a topic for the future. Okay, so we try to match professor. Our option is a pattern. So it's either sum or none. It's exhaustive, no need for a wildcard. And then we try to bind the value inside our option to this variable name, and we're able to use this name variable in our print statement. And so if we run this again, we're going to get the exact same behavior because these two snippets of code accomplish the same thing. So if you see an option and you want to handle both cases, use match. If you only care about one case or the other, use the isNone or isSum methods. Okay, so now on to the result type. So again, from the documentation, the type result, TE, is used for returning and propagating errors. So you'll notice this little angle bracket notation. You probably saw this in option 2. So the T here is the value that corresponds to some success. Okay. The E here is corresponding to the value representing your error. So when you want to return something or propagate an error, you use the T to represent the type you want to return, or E to represent your error type. And you'll see this in the example. So result is an enum that also has two variants: OK, with some T inside, representing success and containing a value, or error, with a value of type E inside, representing error and containing your error value. So this is different than option in that your error actually has a value. When you have an option, you just have some success value, your sum, that contains the success value, and none, which contains no value. So that's the biggest difference between these two types. And again, the use case for result is propagating errors and returning success values. Okay. So functions return a result whenever errors are expected and recoverable. So if you have some type of function that can fail in some way, you'll want to use a result type. And if you want to use that error somewhere else in your program, maybe print it out, maybe send it back up to some logger, you want it to be recoverable, so you return a result rather than crashing your program. So in the standard library, you'll see results used very, very often when it comes to I/O. So reading from files, reading from a network socket, creating files, writing to disk, anything involving I/O, errors are expected. Something can go wrong. You might not have the correct permissions. Something might not exist. Errors are expected, and you want them to be recoverable. So the I/O libraries in Rust use result a lot when returning things. Okay, so if there is no meaningful value that's to be returned as T or E, we can use the unit type, a tuple with no elements inside, in place of the success or error value. That's the sort of standard you'll see in this course. If we expect you to write a function where there's no meaningful value to be returned as successful, you'll just see us ask you to place a unit type in there. So when you have your OK, you'll put the parentheses around or after the OK, and you'll have another set of parentheses inside. So if you see OK with two sets of parentheses, that is OK with a unit type inside. Likewise for error. So this double parentheses is its own type. It's a value. So be careful to try and identify the unit type in case we ask you to. And here's an example. So if we don't particularly care about whatever happens on a success, but we do want some string to be returned on an error, we can say the success type is the unit type and the error is string. Okay, let's see results in action. Okay, so we're going to start off by just going over this divide function. So let's say in this imaginary world, we have to implement divide by ourselves. So there are some particular division errors that can happen, dividing by 0, or perhaps if you're dividing integers, you can have a truncation error. So these are the only two division errors we care about in this world. And we're dividing two numbers. And so we know our division can have errors, and we want that error to be recoverable. So we're going to say, whenever we try to divide, we're going to return a result type. If our division succeeds, we'll return an I32 as our success value. If our division fails, we'll have some type of division error enum that has some information about our error. Okay, so if the divisor is 0, we know that that's a divide by 0 error. So we'll return an error, ERR, and then parentheses goes the value we want to be inside. So again, we're declaring our enum, division error, : and the value that we want it to be. Likewise, if the numerator is smaller than the denominator, we're going to have this truncation error. Any other case, it's a successful divide. We can return OK, and all is well. Okay. And then we have this sort of error handling code to match our divide result. So we'll call divide on A and B, and we'll match whatever calculation that happens. So if we successfully divide, we'll print out something divided by something equals our answer. If we see some type of error, we'll have some error printing code. So I want you to notice that we're doing variable bindings on both cases. So if it's a success, we have our variable in here, calculation, that is the result of our division, and we're going to end up printing that out later. If we have a divide error, then we're going to take that division error and try and match it. So I want to point this out. We have nested match statements. So if you have an error and you want to try and match that error or do something with it, or even success, you have some value and you want to continue using it. Maybe it can be a variety of different things. You can have nested match statements. Please take advantage of this in MP0. It will make your life a lot easier. So nested match statements, very handy. Use them if you can. Okay. And then up here we have a bunch of tuples. So 10 divided by 0, 1 divided by 100, and 20 divided by 4. We're just going to call match divide result on all of those. Okay. So as we expected, 10 divided by 0 errors out. So what divide returns is an error variant with the divide by 0 enum variant inside. And then match divide result gives us this little error message. And then 1 divided by 100 gives us also an error with a truncation error inside. This is also a separate enum variant. And then we get this little print message here. And finally, if we are able to successfully divide, we get an OK with the result of our division inside. And then we can print out that calculation. Okay, so lots going on. The big takeaway is when you're using OK, error, some, or none, use this variable binding syntax to extract the value inside your enum so that you can use it later on. Please, please, please avoid unwrap wherever possible. Okay, so some useful options on, or useful methods on option and result. I'm going to briefly go over these. We are a little bit behind on time. So is sum or is OK? You saw is sum in the example with option. Is OK is the counterpart for result. Is none is error. Again, you saw is none. Is error is the counterpart for result. Accomplishes the same thing as is none. There's this function unwrap or. So try to extract the value corresponding to success, either sum or OK. If there is no sum or OK inside your option or result, give me some default value, and you specify that. So a little bit better than just unwrap by itself. Okay, use these with caution. So expect an unwrap will crash your program if they are called on a none or an error type. Expect will print out a message that you pass in. If the code panics, unwrap will simply just panic and print out the line number where it happened. Please use these with caution. Please try to avoid them if you can. They're difficult and very annoying to debug, so you will make your life easier if you use match statements on options and results. Okay, and like we said, you can match option and result, and the patterns you have must be exhaustive, so you must list out both sum and none if you try to match it, or use a wildcard. And you can extract the values that are inside your sum or OK or error by using this variable binding syntax. Okay. So I'm going to briefly cover tuple enums because that is what sum and both result types are. So Rust allows you to bundle additional information into your enum states. So we can create named tuples using our enum variants. So in this example, we're creating a point enum that can either be 2D, 3D, or 4D, and we have a tuple that is attached to our enum state. So this is all that option and enum are. They're simply just, an enum variant with a tuple of one value inside. In this case, we have tuples of 2, 3, and 4 values. You can have as many as you want, but you can attach tuples to your enum variants. And to declare them, you simply just declare the enum variant and then the tuple of whatever you want inside. Similar to how you declare sum, OK, or error. Okay. I'm going to skip over this. We'll talk about this in a later lecture. That's all for today, folks. Thank you for watching. This lecture was very dense, but it will help you a lot on MP0. So please rewatch this. Please use the lecture slides. They will come in handy for MP0. Take care.